Hi guys, welcome to Learn Electronics Repair. I have an amplifier here for repair, and I've had this amplifier before, so I actually fixed this on a previous video. It was working, but it has an intermittent fault, and intermittent faults are, generally speaking, a right pain in the ass, or they can be, to find. So I'm going to try and demonstrate the fault on this. I think I can probably get it to do it. We'll see if we can actually fix this, and we're going to talk about various techniques we can use to find intermittent faults, and I'm sure you guys will probably have some more suggestions as well. So let's see if we can get this to misbehave. The lights go out on this channel, signal light is stuck on this channel. Yes, it has a noisy fan, but can you hear that kind of like purring noise on one speaker? Yeah, so that's the problem with this, but in fact this is intermittent. Let me show you. One common factor with intermittent faults is they tend to react to external influences. So generally an intermittent fault will occur, for example, when something is hot or cold and it works in the opposite condition, or it can be vibration or physical shock specific, like you thump something and it comes on. Yeah, it might run for some time, go off again, give it another thump, it comes back on again. Of course, that's a good technique, and knowing where to thump it can be quite valuable to know. Yeah, but in this one, I do know this is actually physically reacting. So this will work. You give it a bash and it goes off. And I think that the problem is in this area. Now, we'll see. So we're going to take this apart and put it back together again. What we have here is 3 modules all stacked up, or 2 PCBs plus the main board. And this is where we were bashing it on the top of the amplifier, and that was causing the failure. We have one set here. This is for the right hand channel, this is the left hand channel, it's the right hand channel that has a problem on the front indicators. So first of all, I'm just going to take these PCBs off, put them back on again, and see whether that actually clears the fault. To do this is not too difficult. We need to get some of these connectors out of the way first. So we have one here. Okay. I need to get down to this end of the PCB. There's a screw down there. These wires are in the way, so these are coming from the power supply, and I can unplug these one end or the other quite easily. I think this end is the easy way, so we can just lift these off. Okay. And there's another connector again here, so there are multiple connectors. That one is in the way, this one is in the way. Okay. So this plugs into the main board. Quite a tight fit in here. Okay, and we can see this connects via all these pins along here into a socket on the board. There are some power devices, these are your output devices underneath, and sandwiched with this is another board. So this one fits onto the top of the other one. Okay, like so. This is covered in this kind of like conformal coating. So if this module itself is where the problem is, we probably just need to replace it. I can get these modules and they're not too expensive. Okay, the only problem being that they will not ship them to the Canary Islands, so I have to get them sent to an address in Europe, a friend, and then they quite happily send them to the Canary Islands. So there you go. Let's just put this back together. So we're not going to try to find where the fault is at the moment. I just want to see if the fault is definitely somewhere in this area. So I'll try to reassemble this, put it back onto the amplifier, and let's see if it works. Okay, so it's back together. Is the fault still there? Power on. Yes. I'm just tapping this with the end of the screwdriver, an insulated end. And it doesn't seem to make any difference. I was just waggling this around a little bit, and I see down here there's a mounting point for this PCB which doesn't have a screw in. When I just took this off, there was only the one screw at the end. Now, it's possible that those mounting points are also the grounding points for this PCB. Sometimes a device is built in such a way that that is also a ground connection. It needs to have a connection, and without the screw in, it might not be making a good connection or no connection at all. So that's a possible cause for an intermittent fault. We can have a quick look. If we can see that underneath this screw hole on here is a definite connection, it's clean metal that connects to the pillar that's under there. Yeah, that might be the case, and putting the two screws in might fix this. So let's have a look. I'll try and leave these wires on this time. I think probably I don't need to disconnect those to get this out. This is quite stiff again. Okay. So that appears not to be the case. If that was the case, then this is the metal threaded pillar that it attaches to, and there would be a ground point here. We don't see one. I think what I'll do now while I have this out is what you should probably always do with an intermittent fault. And I do know it is in this area because I've seen this work before, and thump the thing and this channel goes off. It could obviously be a problem down on the main PCB, but these are quite easy to examine under the microscope. So let's take this apart again. Let's do that. We can mount this screw in anyway. We can try it again. Okay, so I have these two PCBs. Let's have a look under the microscope. If something is triggered by vibration, basically, or a physical shock, an intermittent fault, it's very likely to be a bad connection somewhere. Now, that could be internally in a component, which is very hard to find. Hopefully it's going to be something external so we can actually find it. Now, by external, the most likely things to fail in this sort of way are switches, micro switches. If there are any jumpers on here, you know, like the little jumper pin things, the jumper caps, they're a good possibility. Cracked and bad soldered connections is another one. And heavy components. So if something's quite a large, heavy component, it's more susceptible to that kind of failure just because of its physical mass, basically. Now, this board you can see is covered in this black conformal coating. We really cannot see on this side, so that is very difficult to find. I think I may have a way there. We'll have a look. I can actually replace this. I can get these, okay. Let's look at the other side. So this is, I don't know, it's like a relay or something maybe. Not marked. It has, no, maybe not. It may be some sort of inductor, like an isolation type thing with two coils that maybe audio passes through. We can see this is a bit messy down here. Yeah, you can see that stuff on it. I'm going to look at the condition of the various pins. So this is what connects the boards together. This is a very likely failure point for this type of fault. Just try to focus that. Yeah, that's quite well focused. Enough to see if there's any corrosion. They look okay. The middle ones, they also look okay. That might be a bad joint. You see this one that has like a circle around it here? That is typical of how a bad soldered joint would look. So it fails literally in a circle. So as we're inserting this into the board, the pressure is pushing that out a little bit. That could be the fault, or a fault. Doesn't help again because this is got this coating on. I think I'll clean this up with a bit of isopropyl alcohol and see if I can see better. Try to get some of the worst of this gunk. Again, just looking at this side, we have the one here, which has like this circle around it again, whereas some of these don't have that. Can you see the difference? So those are ones I would suspect, okay? This is the other board. Again, we'll look at these connections down the end. So you can see some are soldered and some are not. They don't have any tracks to go to. They can't be soldered on the other side because you can't get under there. So let's have a look. These look okay. Of course, we can use the technique of just resoldering them all. But once again, I think I would like to clean this up with a bit of isopropyl alcohol and see if that shows anything up a bit better. That's another one that has that kind of like fracture or ring around it. You see it there. Okay. There's a bit of a mess under here, so I really will try and tidy this up. And then we can have a better look at all these soldered joints, I think. I've cleaned this connector here, isopropyl stiff brush. I then just use this, so this is just a strip of pin header, and I repeatedly inserted and removed this. I found this easier to do than using the actual PCB, so I just inserted and removed it a few times. Let the ISO dry out. Okay, I want to have a good look down here because from this angle I can't see if I have any bad connections. Let's see if we can find any. It's really hard to see in there. I don't see anything obviously bad. I may be better taking this entire PCB out and checking from the other side if I have any cracked joints under here. Okay. This would be the sort of area you might find a cracked soldered joint on a component near here, because when you push this in, effectively it flexes the board, and the top board has like these little rubbery things over here, so they effectively push against the top of the case, so it sandwiches the board in between. Therefore, any sort of shock on the top of this would effectively be transmitted down into the bottom PCB. Another good place to look for cracked joints and that sort of thing, I mentioned switches, these connector strips. Relays is a very good one. If you tap on a relay, maybe you can cause a failure, so you know it's the relay itself or the contacts inside the relay. You may be able to dismantle it and clean it, or you may just replace it. Hairline cracks in the solder joints, we've talked about that, but you could have a hairline crack in a PCB, so that's something else. But you should be fairly obvious if you use a microscope. You should be able to find that. Dry soldered joints we've talked about, that's a common one. One you might not think of, but is quite common, are trimmer pots. So that's these type of things. These are very prone to developing bad contacts between the wiper and the track. So that's a very likely place to find a bad connection. Again, by gently tapping on it, hopefully you will be able to trigger the fault or remove the fault. So those are the main places. You could have cracked components, especially resistors which are cracked. That normally happens more in larger power resistors. If you see resistors that are obviously running hot, that might be a reason to suspect those components. Again, just give them a gentle tap, not with something like this, but something insulated. See if you can trigger the fault or remove the fault. And another one is corroded leads under electrolytic capacitors in particular. Tap on it, you may be able to trigger the fault or not trigger the fault. The ceramic tap capacitors also crack, but they tend to go short circuit. So although a short circuit capacitor could cause some fault and it's intermittent, quite often they'll cause something a bit more drastic to happen. Okay, it's generally an issue of trying to pin down the fault to a certain area. Okay, now I have noticed something since I was cleaning up these boards. This one may have bad soldered joints I was describing, with the ring around that one in particular, and maybe this one are broken. I think you can see them more clearly now. Okay, same here, that looks fractured to me. I'll probably need to resolder these, but I have another one of these boards off the other channel, and although they're not quite the same, I'll explain why in a moment. I can interchange them, I think, so that's something we can look at. On the other board, now I've cleaned this one up, I noticed something in particular. So you see there, that pin is shorter. That means it's pushed back into the board, and so has this one. Now, it looks like, in actual fact, these pins are not actually soldered. That's in fact why they've pushed into the board. Just try to get that so it's in focus. You can see that moves. That one also moves, but they are not soldered, so that isn't in itself the problem, but it's something you should well look for. Okay. These sockets look okay. There is some corrosion around these areas, but I'm not totally convinced the corrosion itself is what's causing the problem. But what can cause a problem is this type of glue. So this glue can go dark, it normally becomes conductive. That can cause intermittent problems. This looks okay, it's flexible, silicone, but anything dark is something you should remove, to be quite honest. That often causes shorts that cause something to go bang, but it could cause an intermittent problem, of course. Again, high wattage resistors. These components which are larger or higher wattage are more likely to run hotter as standard, and this is a place where we can find bad soldered joints sometimes. Okay, but they sort of look okay. And the pins inside these, so these all look nice and clean to me. Bear in mind the fault could easily be in the connector that plugs into this. Okay. Right, let's see if we can pin down this fault a little bit more. While we're doing this, let's have a look at the condition of these connectors. So a physical examination, this looks okay. Yeah, it looks okay. We'll go with that for now. This doesn't look quite okay. We can see possibly we have some broken wires here. Certainly stressed. Okay. Let's see if we can get that under the microscope as well. Yeah, we can see that the insulation has broke away. We can see the wires inside there. Okay. That side doesn't look so bad. I don't think they are broken. This type of connector, IDC connectors, insulation displacement connector, are really quite prone to failing. We can see that inside here we have like some little metal prongs with a slot in between them, so the wire fits into the gap. You squeeze it together with a special tool or some pliers. These pierce the wire and make the connection. Okay. This one at the end is a bit hard to see because of this glue, but I think it looks okay down there. The problem with this, if this is faulty, really we need to get some more connectors and some more ribbon cable and make up a new one. That's the only way to really fix that I know of. Okay, so I've put this back together again. Let's just try it again and see if it is working now or if we have the same fault. Okay, so we have a visual indication as well here. Switch it on. Yeah, the lights have all gone out now and the fault has gone. We don't hear that noise on the speaker. So we definitely have a problem in that area. The problem is, did we really fix it by cleaning it? So the fault hasn't come back. It looks like in this case cleaning it actually solved the problem. We have some pins which look like they have this possible broken dry joint, the ones like that little ring around, but they're not always bad that look like that. You can't always say. So I would probably say now, yeah, to put the screws back in here, try it once more. I'll fit the missing screw, and if it works, I would say give this back to the customer. Yeah. So let me put the screws in. Let me just try it again. I've replaced the screws now on this, so it's all bolted down properly. Again, we can just give this a try. Power it up. Yeah, and the fault is gone. Okay, the lights are out. Okay, so we do seem to have fixed that one. Once again. Okay. While we're here though, let's just chat a bit more about intermittent faults. We chatted about trimmer pots, obviously also potentiometers. This is like the old-fashioned volume controls before we had touch button. Bass treble controls, they tend to fail. In amplifiers, vintage home amplifiers in particular, the multiple switches tend to fail. This is things like the source selector switch, phono, tuner, cassette, okay, and things like the mute switches. Those do tend to fail quite a bit, so that's one to keep in mind. Although I didn't need to with this one, another technique would be to take this module from this side and put it on this side and so on. Now, this amplifier has a bit of a quirk, shall we say. So although we can swap these modules over, they will swap over, it's not a problem. They're not the same, so we have a type A and a type B. And the difference between the two is that these are class D amplifiers. This is the audio processor module, and the frequency of the pulse width modulation is different on the two. Normally speaking, that isn't really necessary, but this can become necessary in amplifiers which can be used in bridge mode like this one, where both channels form one amplifier to give more power, often feeding into something like a subwoofer. And you can have a problem whereby if the pulse width modulation frequency is the same on both channels, but one isn't quite the same, or one's drifting in phase slightly on the other one, it may form a harmonic low frequency which is audible, and you can get an audible sound. So to stop that, we have different frequencies on these, but you can still take this and put it on that and vice versa. Okay, so that would have been another way to swap the top boards. Is the problem still there? Then the middle boards, and if we pin it out eventually, so either this pair of boards or this pair of boards will only fail on this channel, then we're down to the main PCB. We need to take this out, and initially again I'd be looking for bad soldered joints where this big connector attaches, and underneath any of the power devices, things which generally get hot. So that's probably the best technique with that sort of fault in that scenario. Another common problem which can be intermittent, and this is more on digital equipment, so motherboards, graphics cards, this type of thing. But not only that, sort. I mean, anything which has a digital section of it. We get hybrid devices like, for example, air conditioners, which are partly digital circuitry, partly analog, if you like, circuitry. And in those cases, if the device is just behaving strangely, I would consider, first of all, looking for any electrolytic capacitors which are bulged. But if you don't see any, you can try tapping on them to see if you can emulate a fault. What you may not do, I would suggest you change the electrolytic capacitors first if you're going to start swapping or exchanging components. If you've got to the point whereby you need to start changing components, that can be helpful on a board like this, where, for example, we have one channel working, one channel not. We know the fault is on the main board somewhere. Is swapping components from one side to the other, a few at a time, or even one at a time, or maybe like a pair of resistors at a time. I'd start with the heavy components and the power components if you can do it, and see whether you can get the fault to go to the other side. That's time consuming, depends on how much time you want to spend repairing the thing, but it's an option. Fuses, especially these fuse holders, you can get bad connections, okay, on the fuse holder. So that's something else to look out for. And something which is physically close to where you think the fault is. So, for example, you were tapping on this thinking the fault is here, but possibly the fault is there because it's very close by. The best way to do this is you start effectively like thumping the thing so you know it's intermittent, and then try to pin it down so you're going into a smaller area, maybe hitting things a bit more gentle just in that area to see if you can pin it down closer, okay? So that is the way I'd suggest you do that, rather than just continually thumping the thing in one place. Now let's chat a little bit about heat-sensitive intermittent faults. So, two types. Either the thing fails when it warms up, or it's difficult to get it going. After a number of attempts, it eventually starts, okay? So the fault can be active hot or active cold. I would probably say active hot is more common, but certainly I've seen the other type of fault, okay? The best way to try and pin this down is using hot air, but not set very hot. Turn the temperature down quite low, below 100 degrees, down to the sort of temperature that the thing normally fails at anyway. A hairdryer might be a better option actually for that. And another way you can do it, if you want to try and pin down the fault where you're not spreading heat too broadly, like if you know the fault is here somewhere, or here somewhere, not underneath me. Something like a 12 volt bulb, a car bulb, not the LED ones, they don't get so hot. Stick some heat shrink over the end so you can't short it against anything, and then effectively just rest the bulb in the area you think the problem is. This will get the heat quite quick, it'll get hot quite warm. You don't have to rest it on, you can just position it so it's very close, okay? And that will get heat into one area quite well. Obviously heat rises, so if you can do this with the thing the other way up, great. But that's quite a good way to get localized heat into one area to see if, again, you can pin down where the problem is. This sort of fault, again, can be bad solder connections, so that as things expand at different rates, the fault comes or goes. It can also be things like resistors with cracks in them. Capacitors are quite prone to failing in this way as well. But also semiconductors can fail quite often in this way. Transistors, particularly bipolar transistors, maybe a bit less with MOSFETs, but they can fail in this sort of way. So once again, it's a matter of trying to pin it down to a smaller and smaller area so you can get down to where the problem is. It may be you don't have a faulty component. I'll give you a couple of good examples. If like a resistor is touching a capacitor, just from manufacture, move it away, just get the heat a bit away from the capacitor. That could be causing it to fail. No faulty component, just literally something touching something else. Resistors are probably components that are more likely to get warm during operation, especially large ones. That's why they are large. So look out for that sort of problem. And although it seems very obvious, but you may not think of it, check the heatsink compound. We would do this on the CPU, yeah. Well, we should do it on things like these transistors as well. If they have like a bolt through and they have the heatsink compound, if the heatsink compound is dried out, that can cause this sort of thing where once it warms up, it fails. Obviously, noisy fans. This does have a noisy fan, but it does spin. Probably these want replacing, to be honest, in this one. I'd have to get some of the right size, but certainly fans that are not working properly is another good one that will cause failure when hot. The other good way, obviously, to figure this out is not only heating things up, but also cooling things down. You can see how long I've had this one. It's Mapling. They went out of business quite a long time in the UK. This is freezer spray. Now, you can get this from AliExpress, various other places. So literally when we spray this on the components, it quickly reduces the temperature to -50°C. This would normally have a little plastic straw, if you want to call it that, little tube that fits in there to direct the cooling into a particular area. I've actually lost mine. And you can see it freezes things, yeah. Okay, you see the frost. Now, the frost is not this stuff. Okay? The frost is, to a good extent, condensation, if you like, in the air. Humidity from the air. Now, I would be a bit careful of doing this sort of thing on high voltage equipment that's powered up. Okay? The freezer spray itself is non-conductive. This will not conduct. But you may, if you're unlucky, get enough moisture out of the air that will. Yeah, so just bear that one in mind. The main technique with this is to wait till the thing fails and then cool different areas down until you find which area is causing the problem and then try to pin it down further. I would normally go for something like just this whole area, just the same on the other side if we don't know which channel it is with an amplifier. Different places, yeah. Bear in mind an intermittent fault on something like this can quite easily be caused by a problem in the power supply. So there's a problem with the regulation or smoothing of the power rails, okay? Although that would, you would think, affect both channels, but wait till it doesn't because of some other slight issue with tolerances, okay? At the end of the day, a lot of things can catch you out, but if you're aware of them, you have a good chance. Another good idea you might try, whether it's going to help you or not, is using a thermal camera. So when the thing is running, yeah, thermal camera, have a look around. When the thing fails, again with a thermal camera. Now, obviously, the whole thing is warmed up, but it's possible that you will spot something if it's caused by like a crack in the resistor, which is arcing slightly or breaking down, or a capacitor which is breaking down with temperature. You may see that something is notably hotter than it was compared with everywhere else, or notably colder than it was compared with everywhere else. Don't forget that one, okay? Even if it's a fault that happens when the thing is warm, you may find some large component that's actually now cooler. Yeah, that's because there's no current flowing through it. It may not be that component which is the fault, but at least gives you an idea where the fault is, okay? Another one, by the way, things like capacitors and resistors that are in contact with the heatsink accidentally. I don't mean a temperature sensor that's supposed to be in contact with it. I mean something leaning against it which is not supposed to be in contact with it, okay? That's another good one. It's like a capacitor against a hot resistor. Okay, guys, so that's all I can think of at the moment about finding intermittent faults. It's not an exact science, and I probably didn't think of everything I should have done, but it's possible some of you guys have thought of something else, yeah, or would like to expand on something I mentioned. So get into the comments below, let us know any interesting stories you have with really weird intermittent problems and what was causing them. I'm sure we're all interested to hear, or any different techniques you would recommend. So I think there's one thing left to do on this video, and that's just to play out with a bit of music on this amplifier and make sure it's working properly. Okay, power up, lights are out, music. Yes, I can tell you the northern solar is coming out of both speakers equally, so that is definitely fixed. We can see the signal lights are flashing on the amplifier correctly. Okay. So, guys, we have one good fixed amplifier. Hope you enjoyed that. I look forward to seeing you all soon on Learning Electronics Repair. Ciao for now, guys.